Well, hello, welcome to Stats. We're going to be looking a little bit more at this idea of creating scatter plots, and we're going to also to look at the how do we know whether there is a correlation between two events. Now, the idea behind correlation, the one thing we need to make sure we're clear about, is the idea between causality and correlation. To prove causality, which means that one event causes another event to occur, is far more difficult than proving that one event occurs the same time that another event is occurring. So when we look statistically, we're doing scatter plots, we're not necessarily trying to prove causality because that sometimes requires an enormous amount of data to be able to prove causality. What we can do a lot of times is prove that there's correlation, which means that these two events go hand in hand with each other. When one happens, the other one happens. All right, so that's what we're doing right here. So we're dealing with correlation. We're seeing, do these two events occur concurrently with each other? And as one increases, the other increases, or as one decreases, the other increases. Is there some type of behavior between those two that is predictable? So we looked at another example in another video where the information was not predictable. There was no way to say using one piece that the other piece would occur. So here's the data set that we're looking at now. I have a year here. And actually, what I'm going to do here is I'm going to insert. I'm going to go right here and I'm just going to insert a row above that. So I have the year. And then my next column here is boat registrations. So what we're looking at here is the number of boats that are registered in Florida. I think this is for a particular area of Florida. In this next column is the number of mantas that were killed. Okay, and if you don't know what give you some context behind this, mantas are a freshwater mammal. They look very much like walruses, but they're very different in a lot of respects. And first and foremost is that they live in more of a still water or slow-moving bodies of water. They don't like to necessarily get up on rocks and beach themselves the way a walrus will. They're a lot more docile than a walrus would be, and they live almost exclusively. This particular species at least lives almost exclusively in Florida, in the waterways, the slow-moving waterways of Florida, in the freshwater slow-moving waterways in Florida, and they're very appreciated creatures. A lot of people really appreciate them for their majesticness. So the column B here is the number of boats registered in a particular region of Florida. And this is the number of mantas. This column C here is the number of mantas that were killed that year. Okay, that same year. And then, of course, here's the year itself. Now, a lot of times whenever we do deal with statistics, we don't necessarily leave the actual year. So here's 1997. What we do is we talk about it being in terms of other quantities. We started at some other value. Say maybe we started at 0 and we work our way up from here. So 1997, and what I'm going to do is I'm actually going to insert a row there, and that inserted in the wrong spot for me. So I'm going to move that over to right here, and I'm going to write this as the year since 1997. Okay, and then I'm just going to make this entire column here. I'm going to wrap that text just so it's a little easier to look at. Because I'm going to need a little bit of space here. Okay, and then right here I'm going to make this year 1, and then I'm going to make every value after that the value before it, this one, plus 1. And then I can just copy that, and then I can paste it in that entire column. I could actually highlight the entire column and paste it that way, but I only have the 39 years to look at here, so it's not a big deal for us to just kind of cut and paste that as like that. Now what we want to do is what are the relationships that we're concerned with? So let's start with the year and boat registrations. Okay, and we're going to look at this a number of different ways. Now, if we're concerned with the number of years and the boat registrations, how that's changing as the years go on, we'd pick these two pieces right here. But the main purpose that I was wanting us to focus on was the idea of, what about the mantas? Is there a relationship between the mantas and the years? Is there a relationship between the mantas and the boat registration? So we can look at both of those. So what we're going to do is and in the order in which we picked this does matter, right? We're going to click column B, and then I'm also going to do column D like this. So column B and column D, those two rows. I'm not going to use my shift key. I'm actually going to use, I'm a Mac user, so I'm going to use the command key there. And then I'm going to go up here to insert and then I'm going to get my scatter plot. And again, if you don't remember where those are, you can just kind of click on any one of them and just put your cursor on it and hover it for a second, and it'll tell you which ones you're working on. So this is a scatter plot here. So mantis killed versus the year. Does it look like there is a correlation between those two events? If I were to draw a line, there most definitely appears to be a connection there with those two pieces. All right, so the number, as the years go on, the number of mantis being killed is increasing, except as you get towards the end here, it starts to drop off a little bit. Okay, so let's try another one. Let's go here. Let's check the boat registration versus the manta being killed. And again, I'm going to go back to insert, pick my scatter plot, and then set that one up there. So when we have more data, we can look at more situations. Okay, and when we look at that, that is a tighter knit collection of data, in my opinion. As the boat registrations go up, the number of mantas being killed goes up, and we don't really see it go down a whole lot. And that looks to be a little bit more of a better fit than over here. Like if you look at the actual data, the years go on, we actually see a drop off in the number of boat registrations right here as we approach 2015. It doesn't drop off completely, it does drop off a little bit, and then it picks back up a little. So we don't necessarily see the boat registration constantly going up. And when we identify that occurring, it might be a pretty good indication that we probably want to connect these two pieces of data as opposed to looking at this one over here where we're constantly seeing this increase here and what's happening with the other piece there. Now another piece we can do is we can click on this one, and I can go to add chart element, and then trend line, and then linear. Okay, and I can double click on that line that's created, and it's a pretty good fit for that line. And then I can go over here, display equation, and display R squared value. Okay, now when I do that, it's kind of hard to see it, it's small, but I get a slope of 0.07 and an R squared value of 0.8. So there is some slope there between those values. There is some type of relationship between those pieces, and the R squared value of 0.8 is pretty solid. That's a pretty good indicator. Can we do better though? Because it's not just saying, oh yeah, that fits. Let's move on, saying, oh, it's just as the years go on, because that's a completely different argument. We're saying that as the years go on, more manta are going to be killed. There's not really anything we can do about it because the years go on. We can't stop the years from occurring. Well, let's do the other one. There's that trend line. That's a really solid fit. It actually goes through the data really well. We double click on that. All right, and we can add an element. We can display the equation and the R squared value, and when we do that, we get with a correlation. Go ahead and close that out. We get a correlation of 0.12 as the slope, and we get an R squared value of 0.9. That 0.9 is a better indicator than the 0.8, which means that there is a stronger correlation. There's a stronger relationship between boat registrations and the manta that are killed every year, meaning that as registrations go up, the number of manta that get killed also goes up as a pretty solid indicator. And this makes sense. If you don't know much about the region of Florida, these waterways are very narrow most of the time. You're talking about a waterway that would fit a small speedboat, maybe two of them side by side, but even that would probably be a little bit of a problem. If you had a party barge, a pontoon party barge, they could probably pass each other if they were careful in most areas, but there'd be places where that'd be pretty much the entire width of the waterway. So you do have to be kind of careful about navigating some of these places, and the manta are slow-moving creatures, and boats are normally not slow-moving, so there would be an issue with that. So it makes sense that you would have a strong correlation between the number of boats on the waterway and the number of manta being killed in the water. This is kind of similar to having a bunch of cars on the road in an area that has lots of deer. That's kind of the same situation, except deer are a lot more elusive and they can move around a lot easier. They're more agile. Manta are slow-moving creatures, and they're not terribly fast or agile in the water. They're big creatures. So a fast-moving boat is going to strike them and hurt them quite a bit. And I mean, a lot of times it's the prop of the boat that's going to hurt them the most. So anyway, there is a pretty strong correlation. You could use this to inform policy. Maybe you look and say, well, the population is dropping off fairly badly when you look at that data. And we can't sustain that. The population killing more than 40 mana a year is unsustainable. So we need to have boat registrations that are below that mark. And then actually we can look at the graph here. We can see, well, what does that look like here? And we can actually hover on a piece there and see right there that 34 manta were killed when the boat registrations were 559. So maybe we make an argument that the boat registrations need to stay below 600 in order to maintain a population so that we don't lose more than 40 mana a year. I'm not basing that anything on anything particular, just kind of picking a random number there. But that could actually inform policy. And some people are like, well, why would we want to restrict boat registration? That seems un-American. Well, when we're talking about maintaining an ecosystem, and that's the argument I'm making with this piece, is if we want to talk about maintaining an ecosystem of some sort, we probably do want to put some regulations on that to protect the ecosystem if that is our goal. If our goal is not that, then why are we looking at this data in the first place? The purpose of looking at some of these data is to help us inform policy. So if we wanted to be able to say, well, we don't need to regulate the number of boat registrations, and we want to base that upon some type of data, we haven't found it yet. We need to keep looking, because this data actually says the exact opposite. There is a direct correlation. There's a strong correlation between the number of boat registrations and the number of manta that get killed. And this, from a policy perspective, would say we need to somehow or another deal with that, either through regulating the number of boats that are registered, or doing an education program to make sure that people who own boats and are registered in those areas are aware of the manta, or maybe we just restrict movement on those waterways entirely in order to protect that species, because it is actually I don't think they're endangered, but I think they are one stage below in front of that. So it'd be something that you'd want to look at if you wanted to protect that system. All right, so this is an example where you actually do have strong correlation. I've done a couple of examples where there were not strong correlations, so I wanted to give you that example to go by as well. Again, please reach out and ask questions as needed. Let me know what other types of videos I can put out there to help you understand this information better. Take care.